Hello everyone. Hope you all are doing great. Guys, today in this video we are going to understand some advanced topics of OSPF protocol. Before starting the session, I must tell you OSPF is a very important routing protocol that most of the organizations are using in their network. So if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. Even you are thinking that I know OSPF. Guys, I am damn sure if you will watch this video till the end, definitely you will learn something new. Okay, so actually my main goal of this video is to make you understand the path manipulation in OSPF because traffic flow is very important. Okay, so this video will guide you to understand the path manipulation in OSPF. We are going to use lots of advanced commands in OSPF. Maybe you know or you don't know, but I am damn sure you will learn some new concept today in this video. Okay guys, so now without wasting our time, let's begin the session. Before configuring, let me make you familiar with this topology. As you can see here, this is my router 1 and router 1 is connected with one ISP. Okay, we are not going to use this part here in this video. See here first, this router is connected with router 2 and this is my OSPF area 0 domain. Okay, here I am running what EIGRP 100. So this is my EIGRP domain. So this router will become what ESBR, because here we need to perform redistribution. So here we will redistribute EIGRP prefixes in OSPF domain and OSPF prefixes in EIGRP domain. So this router will become ESBR, and as you know, ESBR generate what LSA 5 to share external prefixes in OSPF domain. So through LSA 5, router 1 will receive these all prefixes. Yes or no? Yes. After that, see here, router 1 is connected with router 4 and router 5. And router 4 and router 5, one interface are in area 10 and one interface in area 0. So these two router will become what? ABR. ABR and ABR. And suppose here we have some prefixes. So these prefixes router 1 will receive in the form of LSA 3. And as you know, ABR is responsible to generate LSA 3 to share intra-area prefixes in OSPF. Yes or no? So actually, all router in OSPF domain generate LSA 1, but LSA 1 cannot cross area. So that's why ABR router is responsible to generate LSA 3 to share the network information of inter-area in OSPF, right? After that, these two ABR router is connected with one router number 7, right? Router 7 in same area in area 10, and router 7 is connected with one more ESBR router. Here we are running what? EIGRP 200. So this router will also become what? ESBR. And guys, here also I am running same network, which here I am running 60.1.1.0, 60.1.1.0/24. So router number 1 will receive this 60.1.1.0/24 prefix from router 2 also, and from router 4 also, and from router 5 also. Yes or no? Because router number 8 will also generate what? LSA 5 to share external prefixes. So through LSA 5, router 1 will receive this prefix. Yes or no? So question is, router 1 will install this prefix in their routing table or this prefix in their routing table. Okay, if router 1 will by default install this prefix via router number 2, then we will understand how we can manipulate the path. Okay, after that, here you can see router number 7 have two paths to reach ISP or this network 10.1.1.0 network. So here also we will understand how to perform path manipulation. We will understand summarization in OSPF. Lots of time we have discussed summarization in EIGRP, but you know what I see on YouTube, that no one have made video on the route summarization in OSPF. So today you will understand the route summarization in OSPF as well. Okay, so here we will understand how we can manipulate path by using summarization as well. Okay, done. After that, last section is router 1 is connected with one other router, that is router 3, and router 3 is connected with area 1, and through router number 9 router area 1 is connected with area 2, and as you know, two regular area cannot communicate with each other, so we need one backbone area between two regular area. So here solution is router 1, router 3 will not receive these prefixes. So here what I can do, I can create one loopback and I will put that loopback in area 0, so that this router will also become what, ABR, and it will start generating LSA3. Okay guys, so this is my topology. Now without wasting our time, let's begin the configuration. I have already configured IP address, I have already configured OSPF and redistribution on router number 2 and on router number 8. So if I will show you the routing table of router number 8, you can see here I have router 1, and first of all on router number 1, if you will run command, so IP OSPF neighbor, so IP OSPF neighbor, so you can see 2.2.2 is my neighbor, 3.3.3 is my neighbor, 4.4.4 is my neighbor, and 5.5.5.5 is my neighbor. 1, 2, 3, 4. So there are 4 neighbor, router 2, 3, 4, 5. Done. Okay. Now if you will check routing table of router number 1, so see, so IP route. First of all guys, okay, here you are able to see some prefixes with what, with O only. You are not able to see any prefixes with O, but as you know, in OSPF we will get some prefixes with O, some prefixes with OIA, means inter area prefixes, some prefixes we will get from E1 or E2, some prefixes we will get by N1 and N2. So first of all, you have to understand the best path selection of OSPF. So guys, best path selection of OSPF is, here what I am going to do. Now on router number 3, if I will create some loopback in area 0, let me do that. On router number 3, why I am creating loopback, soon you will understand. On router number 3, I am creating one loopback. Interface loopback, let's say 1, and IP address is, let's say 30.1.1.1, 255.255.255.0, and IP OSPF 1 area 0. After that, interface loopback 2, I'm creating 2 loopback. IP address is 30.1. let's say 2.1, and here also I am running IP OSPF area 0. Done. Now here we can, on loopback interface, by default network type in OSPF is loopback, so it will advertise this network with /32, and if you want to verify it, you can verify. So IP OSPF interface loopback 1, here you can see network type is what, network type is loopback. So we can change it. Let me configure it point to point, because now on router number 1, if you will check the routing table, so IP root, so it will receive 30 prefixes with /32, yes or no? So what we can do, we can consider these loopback as a LAN. So here I am going to change the network type. Interface range loopback 1 to, let's say 2, and IP OSPF network, let's say point to point. Done guys. Now on router number 1, if you will verify it, so it will start getting 30 prefixes with /24. So here you can see. Done. Now this router have some prefixes, this 30 prefixes with O. O means OSPF. O means I am getting these prefixes from my own area. So this is the prefix of area 0, because router 1 is part of area 0, yes or no? So whenever router will receive a prefix information with LSA 1, that time it will install in their routing table with O symbol. What I am saying, whenever router will receive a prefix with LSA 1, because 30 prefix router is getting through which LSA? Through LSA 1. If you want to verify it, you can. So if you want to verify it that this router is getting these prefixes through which LSA, you can check database. So IP OSPF database. Here you can see 30 prefix. Where is 30 prefix? Who is advertising 30 prefix? For that you have to check the routing table in details. First show IP root and 30.1.1.0 255.255.255.0. So see guys, I'm getting 30 prefix. Distance is 110, that definitely from OSPF and non via OSPF 1. Okay, so type intra area, last update from 13.1.1.3 on F1/0. Okay, so these are the timer, and this route is available via advertised via 3.3.3.3. So in the database you can check what router LSA of 3.3.3. These are LSA 1, yes or no? So let me open it in detail. So IP OSPF database, after that router, and I am going to open the router LSA of 3.3.3.3, and here you can see I am getting 30 prefix, yes or no? So actually this router is getting 30 prefixes with which LSA? With LSA 1. So whenever router OSPF router will receive a prefix with LSA 1, with the help of LSA 1, it will install in their routing table with what symbol? With symbol. So IP route OSPF with symbol O. Yes or no? Yes. Whenever router will receive a prefixes with in the form of LSA 3, like you can see in the topology, which prefix? Suppose this prefix, the prefix which is running between router 4 and router 7, 47. So this prefix router will 1 will receive in the form of LSA 3. ABR router will generate LSA 3. So whenever router will receive a prefix information in the form of LSA 3, so it will install in the routing table with OIA symbol. And if you want to verify this prefix, what you can do? You can check the database. So IPOSPF database. So here you can see 47 prefix, 47.1.1.0 I am getting from router 5 and router 4 and router number 5. If you want to open it in detail, you can see this is my summary LSA, means LSA 3. If you want to open it in detail, what command you can run? So IPOSPF database, and this time I am going to open summary LSA, and you will always open the LSA in detail with the help of link ID. So link ID is this one, 40. These things we had already discussed in previous video. So this one is my link ID. So now here you can see I am getting this prefixes in the form of what? In the form of LSA 3, router 4 and router 5 is generating. So that's why router 1 have installed this route in their routing table with what symbol? With symbol OIA. Done guys. Okay, whenever router will receive prefixes in the form of LSA 5, like this prefix 60.60 is prefix, yes or no? So router number 2 will advertise these prefixes in the form of LSA 5. So router 1 will install these prefixes in their routing table with E1 or E2 symbol. So IP root 60 prefix. You can see this router is getting these prefixes with what symbol? O E2. Yes or no? And sometime you will see O E1 as well. Sometime you will see O N1 as well and N2 as well. Okay. So suppose here this area number 10 is my NSSA area. As you already know what is NSSA area and why we have NSSA area. If you have confusion in NSSA area, you can watch my previous video on OSPF in the OSPF playlist. You don't need to do anything. You can simply find the OSPF all video on my YouTube channel. So let me show you that also. So here in YouTube, if you will open it, and then you will visit in my YouTube channel PM Networking, then playlist, and in the playlist you will get one OSPF playlist. So here you can see OSPF playlist. Here I have uploaded, I think 10-hour video. So you can see all types of LSA, OSPF network, right? OSPF area concept. So in area concept you will understand the LSA, NSSA area. Okay, so in NSSA area, whenever NSSA area will get external prefixes, it will install it via through which symbol? Through O N1 or N2. And guys, now you need to understand the best path selection criteria of OSPF. So always keep in mind, here I am writing router will receive OSPF prefixes, and those prefixes will be OSPF. All prefixes will be more reliable if it will receive by what symbol? With O symbol, because O symbol means this prefix is from my area. Yes or no? So prefix with symbol O is more reliable than prefix with symbol OIA, intra area, and prefix with OIA is more reliable than prefix with OE1, and OE1 is more reliable than OE2, external type 2, and OE2 is more reliable than N1, and N1 is more reliable than N2. This is best path selection of OSPF. Most of the time interviewer is asking this question. Okay, so what you can do, you can take one screenshot of it. Always keep in mind OSPF route with O is most reliable, and OIA is more reliable than OE1, and OE1 is more reliable than OE2, and E2 is more reliable than N1, and N1 is more reliable than N2. Okay guys, so now here router number 1 have these 60 prefixes, yes or no? But see guys, this router have only one prefix for 60.1.1, only one route for 60.1.1.0 network. But this router number 1 will receive 60 prefixes from router 2 also, and from router 4 also, right? From router number 5 also. How you can verify it? You can check the database. You can check database of router number 1. So if I will show you the database of router 1, so IP OSPF database. So see 60 prefix 60.1.1.0, I am getting it from router number 2. 60.1.1.0 I am getting from router number 8 also. So 8.8.8 is also advertising this prefix, and 2.2.2 is also advertising same prefix, but router is installing it via router number 2. Why guys? The reason is, so IP root, see the 60 prefix 60.1.1.0, router is received, router have installed it in their routing table via 12.2, means via router number 2. Why? Both router 1 is receiving both prefixes with E2, yes or no? E2 with what metric? With same metric. Metric is what? 20. Here you can see metric is what? 20. Metric is 20, yes or no? Okay, from this side also, from router number 4 and 5 also, it is receiving with metric 20. This is seed metric, yes or no? Now suppose router 1 need to communicate with this 60 prefix, the 60 prefix which is running on router number 10. Router 1 never need to communicate with this prefix. So I want to install this prefix in the routing table of router 1. What I can do? I can advertise these prefixes with E1, yes or no? So now router 1 is getting these prefixes with E2 and these prefixes with E1. So as you know, E1 is more reliable than E2. It will install 60 prefixes via router number 4 or via router number 5. This is the first way, yes or no? Second way is what? Now router 1 is getting 60 prefixes from both sides with E2 and with same metric, that is nothing but 20. Then why router 1 is installing it via router number 2 in their routing table? Because what router 1 is actually checking, guys? Router 1 is checking the advertiser. Who is advertising this prefix? So IP OSPF database. Okay. Through this command, router will check that, okay, 60.1.1.1, 2.2.2 is advertising and 8.8.8 both are advertising. Now this router will check the cost to reach 2.2.2 and cost to reach 8.8.8. Where router will get least cost, router will install that part. So router will run what command? So IP OSPF border router, yes or no? Border router. So IP OSPF border router to check the cost, because I am getting these prefixes from which LSA? In the form of LSA 5, and LSA 5 will be generated by border router, that is nothing but ASBR. So it is router 1 is going to check the cost to reach 2.2.2 and 8.8.8 because both are advertising same prefix. So see, the cost to reach 8.8.8 is what? 3, and cost to reach 2.2.2 is what? 1. So router 1 is getting least cost to reach 2.2.2. That's why router 1 is installing 60 prefixes through router number 2. What if I will change the cost on router number 2? See, here cost is what? 3, and here cost is what? 2. Cost to reach 2.2.2 is 1, and cost to reach 8.8.8 is 3. So what will happen if I will change the cost over here? If I will configure cost 3 over here, then now cost on this cost to reach 8.8.8 and cost to reach 2.2.2 is same. So then router will start performing what? Load balancing. So let me show you that router 1 is performing load balancing or not. So on router number 1, what I am going to do? I am going to configure cost on fast Ethernet 0/0 is 3, interface F0/0, IP OSPF cost, and let's say 3. So I have configured cost 3. Now if you will check routing table of router 1, so IP route, where is 60 prefix? See here, 60.1.1.0. Now it has started performing what? Load balancing. Because this time you can see this network is reachable via 15.5 also, 14.4 also, and 12.2 also. Yes or no? Because this time router will check the cost to reach my ABR, my ASBR, cost to reach 2.2.2 and cost to reach 8.8.8. Both are what? Same this time, because I have set cost 3 over here. So that's why router 1 has started performing what? Load balancing. Now I am going to change the cost again, interface F0/0, and say no. This is the first way. This is nothing but path manipulation, guys. Yes or no? Now again router 1 will start forwarding all traffic for 60 network to router number 2. So 60.1.1.10. Yeah, here you can see via router number 2 only. Now what I am going to do here, router number 2 is advertising these prefixes with what? Symbol E2, metric type E2. From here I am going to advertise these prefixes with E1, right? So let me show you that also. Then router 1 will definitely install 60.1.1.0 prefixes via router number 8. Yes or no? Via router 4 and router 5, you can say. Okay, because from router number 8 it will get the external prefixes with E1, and from router number 2 it will get external prefixes with E2, and as you know E1 is more reliable than E2. So let me prove it. What I am going to do, on router number 2 I am not going to change the configuration will be same, because from router number 2 is getting external prefixes with E2. On router number 8 I am going to change the configuration. First of all, let me check how many command I am running over here in OSPF. So run section router OSPF. So I am going to remove this command, say config t router OSPF 1, and say no. Okay, and now again I am going to redistribute EIGRP 200 and say subnets, and then metric type. Metric type, and this time I am going to say metric type is what? 1. Okay, so now on router number 1, if you will check the routing table, so IP route OSPF, here you can see. Now this router is getting 60 prefixes with E1. So that's why it install it via router 4 and router number 5. So E1 is more reliable than E2. Yes or no? Okay. Now if I will set metric type E1 on router number 2 also, then what will happen? Then again router 1 will install 60 prefixes through router number 2. So let me show you that also. On router number 2, what I am going to do, enable config t and router OSPF 1 do so run section router OSPF. Here I am going to remove the redistribution command. Say no, and let me remove this one. And redistribute EIGRP 100 subnets and metric type 1. Right, guys? So here see. On router number 1, again if you will check routing table, so IP root OSPF, you can see 60 prefix. 60.1.1.0. It have installed via router number 2. Okay. So is it clear to you? I think that how E2 is not reliable than over E1, right? E1 is more reliable than E2. Okay. So whenever OSPF router, interviewer can manipulate you by asking the question like this. Suppose I have one router 1 is receiving same prefixes, let's say 10.1.1.0 from two side, 10.1.1.0 with same prefix length. Here it is getting through E1 and here it is getting through E2. So router 1 will install which path? So always keep in mind E1 is more reliable than E2. Done? Okay. Now next thing is N1 is more reliable than N2. So suppose area number 10, this area, I am going to configure this area is as NSSA area. Okay, just for a second, for a minute, and then we will remove the configuration, because I am, I want to show you that N1 is more reliable than N2. Okay, and before that, one more thing is here. Now router 1 is receiving 60 prefixes from both sides, from router 2, 4 and 5, but it have installed it via router number 1. But metric type is what? Metric type is E1. Yes or no? So metric is what? Metric is 21. Yes or no? From router number 2, from router number 5 and router number 4, it will install with what metric? So IP OSPF database. Here we can open external LSA. Okay, this one. Okay, so IP OSPF database and say external and 60.1.1.0. So you can see this router is getting 60 prefixes from router 2 also with what metric? Here metric is 20. This is nothing but SID metric. Yes or no? And here it is receiving via 8.8.8, and here also metric is what, guys? 60. That is SID metric. Now again, if you want to install 60 prefixes via router number 8 via this ASBR, so what you can do? You can change the SID metric. You can change the SID metric as well. On router number 2, I am going to increase the SID metric. So let me do that also. First of all, let me remove this command from here. Say no. And now I am going to add metric over here. Metric, let's say 30. Here I have set SID metric what? 30. So now router 1 will receive this prefixes via router number 2 with what metric? With SID metric 30, and it will receive same prefixes via router number 8, via router 4 and 5, you can say, via this ASBR router number 8 with what SID metric? 20. So it will install which path? See guys here. Again, so IP route OSPF and 60.1.1.0. It have installed it via router number 4 and router number 5. Yes or no? So this is also one way to for path manipulation. We can change SID metric as well. Now again I am going to say no on router number 2. Let me set default SID metric. No. Okay, and redistribute EIGRP 100 subnets and metric type is, let's say, type 2. I'm going to set it type 2. Okay, on router number 8 also say type 2, and let me remove type 1 command from here. Okay, Now area 10, I am going to configure area 10 as stub area to filter what? LSA 4 and LSA 5. Yes or no? Or I can configure totally NSSA area to filter LSA 3, 4, 5. Okay. So I am going to configure totally stub area to area number 10. So on router number 4, what command I need to run? Config T router OSPF 1 say area 10 and NSSA no summary. Yes, this is command to enable what? To configure NSSA area. So neighborship has goes down because stub should match. Yes or no? Area should match. Then only neighborship will work. So let me run same command on router number 4 also, and on router number 7 also, and router number 8 also. So do so history. I am going to copy this command, guys. Router OSPF 1 area 10, this two command. Okay, now let me run this two command on router number 5 also. Config T done. Let me run same command on router number 7 also. Done. Let me run same command on router number 8 also. Okay, now so IP OSPF neighbor. Again neighborship is in loading state, just wait. Yeah, now you can see neighborship state is full. Now on router number 7, if you will run command, so IP route OSPF, so IP route OSPF. So this router is getting some prefixes with what? N2. Yes or no? O N2. These prefixes, 100 prefixes. Yes or no? Because guys, router ASBR is converting. Now ASBR is generating what? LSA 7 for NSSA area, because in NSSA area LSA 5 is not allowed. So IP OSPF database, you can see LSA 7 who is generating 8.8.8.8. Yes or no? And through LSA 7 ASBR router is sharing these prefixes, right? And router will install it with N2 or N1. Yes or no? Now where is 60 prefix? Here it is. Okay, and this router number 7 have not received these 60 prefixes. Yes or no? So IP OSPF database. So you can see ABR router will generate what? One default route in the form of LSA 3 in NSSA area. Yes or no? So this is default route. And so IP route OSPF, so it have installed the default route. Yes or no? Now what I am going to do, here how I can get one more external prefixes. Okay, so on router number 1, on router number not 1, on router number 4, if you will check database, first of all let me show you the routing table. So IP route OSPF, so this router have all 60 prefixes. Yes or no? This one is through N2, and these are with E2. Yes or no? So guys, here this router will install which path in their routing table? If you will check routing table, so you can see in the routing table 60.1.1.0 is available through what? N2. And this router is getting same prefixes with E2 as well. So IP route, so IP OSPF database 60.1.1.0, it is getting from which router? Router number 8 in the form of LSA 7, and it is getting same prefixes in the form of LSA 5 by router number 2. Yes or no? But it is installing which one? It is installing this one. Can now, this is question that why router is installing this path in their routing table. So always keep in mind N2 is not more reliable than E2, because this prefixes router is getting through E2, And this prefixes router is getting through what? Through N2. Yes or? So if anyone is thinking that N2 is more reliable than E2, no guys, this is the different reason is there behind this. Okay, so we will discuss this one also. But what I am saying, E2 is more reliable than N2. Yes or no? So it's this router 4 and router 5 should install 60.1.1.0 prefixes via router number 1 only. Yes or no? But cost is different. Cost from both sides is different, because here you can say if you will run command, so IP OSPF database, so 60 dot, it is getting on which router I am, yeah, on router number 4. So this is, you know, LSA 3 and LSA 7, it is getting from 8.8.8, and this 60 prefix, this router is getting from 2.2.2.2. It will run what command? So IP OSPF border router, and 2.2.2 to reach 2.2.2 cost is what? 2, and to reach 8.8.8 cost is what? Same. Cost is also same. Okay, so soon we are going to understand this also, but before that let me make you understand the different thing. So guys, now we are going to understand path manipulation by summarization, by route summary. So in EGRP we have discussed route summarization, right? And today in OSPF we are going to understand the route summarization. Guys, in OSPF, you know, in EGRP we can summarize the prefixes on any router, but in OSPF we can summarize prefixes on only two types of router. One is ABR router. On ABR router we can perform summarization, and second one is ASBR. Only on these two router we can perform what? Summarization. Here we can summarize LSA 3, and here on ASBR router we can summarize LSA 5. Okay, so in the topology, first of all let me remove the NSSA configuration from all router number 4, let me say router OSPF 1, and here I am going to say no. Okay, on router number 5 also, router OSPF 1, and say no area 10 is NSSA. In the same way from router number 7 also I need to remove it. So IP OSPF neighbor, so neighbor SIP is still there. Config T router OSPF 1, and say no here also, and from router number 8 also I am going to remove this configuration. Config T router OSPF 1, and say no. Okay, now on router number 7, if you will check the database, so IP OSPF neighbor. Okay, so IP OSPF database is LSA 7 is still there. Yeah, LSA 7 is still there. So run section OSPF. What happened? So area 10 is NSSA, router OSPF 1, no area 10 is your NSSA area. Okay, this command I need to run on all router, no area 10 NSSA. In the same way on router number 5 also, say no area 10 NSSA, and on router number 8 also say no area 10 NSSA. Done. Okay, so now on router number 7 you can verify. So IP route OSPF, this router have not any route from N2. Okay, done guys. Now see, this is my ABR and this is also my ABR. Okay, so these ABR router are generating what? LSA3 to share these prefixes. Okay, and router 7 will install these prefixes in their routing table via both path, via router 4 also and via router 5 also. It will perform what? Load balancing. And here if you want to install these prefixes in the routing table of router 7 via router number 5 only, or via router number 4 only, you want to use only this path to make communication possible between router 7 and this network. How we can perform it, how we can achieve it? First of all, let me show you the routing table of router number 7, that router 7 is performing load balancing or not. So IP route OSPF. So here you can see 10 prefixes. These all prefixes is reachable via 57.1.1.5 also and 47.1.1.4 also. That means from via router 4 also and via router 5 also. Now guys, what will happen if I will summarize the, if I will advertise a summary route from here, right? What will be the summary route, summary network of these prefixes? 10.1.0.0. So because we have 1 to 5, okay, this will be the summary address and subnet mask will be 255.248.0. Yes or no? Because /21. Done. So if I will advertise a summary route, router 1 will install a summary route from here. Yes or no? And it will install all individual prefixes via router number 5. So it will start using this path. Okay. So this is also one kind of what? Path manipulation. Let me do this. How we can do it? On router number 4, I am going to summarize these prefixes. So command will be here. You will run command area 10, not 10, area 0. After that summary address 10.1.0.0 subnet mask area 0. Let me wait guys, let me check summary address. So summary address, after that 10.1.0.0 and then summary mask 255.255.248.0 and no, this one is different command. Actually command is here, we need to define area will be what? Area 0. After that we should use range, I think range, and let me put yes. Here you will provide the summary address 10.1.0.0. after that mask, so 255.248.0 and if you will put question mark over here, nothing. So hit enter. Now on router number 7, if you will verify the routing table again, so you can see so IP route OSPF, still router 1 is performing what? Load balancing. Yes or no? So that means this router is not getting a summary prefix from router number 4. On router number 4, okay, so recording is fine. This command is not working guys. Okay, so let me remove this command once and let me run summary address 10.1.0.0 255.255.248.0 and hit enter. And now on the router number 7, if you will check the routing table, still it is not advertising a summary route. So this is also not a valid command, then say no. And So this command is fine, but here I have to change area. So area is not 10, area will be what? Area should be 0. Let me check. So, and let me remove no as well from here. So area 0, range 10.1.0.0 and 255.255.248.0, this command. And now on router number 7, let me check the routing table. So see guys, router have installed one summary route via router number 4, and router have these all individual prefixes via router number 5. So if you will ping, if you will trace route 10.1.1.1 from router number 7, it will forward traffic via router number 5, not via router number 4. Yes or no? So see, tracing the route to, so it will take some time, not know why it's taking time, but here you can see it is forwarding traffic to 57.1.1.5. this is the IP address of router 5. Okay, so with the help of summarization, we can not only reduce the routing table of router, but we can perform path manipulation as well. So this is path manipulation by using route summarization. Okay, so guys, now video length is around 46 minutes. We will discuss 15 more minutes, right? But we will not make video of more than 1 hour, then it will be difficult for you to watch. Now the next method which I would like to discuss in this video is router number 1 is getting these 60 prefixes and these all prefixes. Yes or no? Now router number 1 will install these prefixes with what symbol? What symbol? With OE1 or E2. Let me show you. So IP route OSPF. So see, this router is getting prefixes with E2, and with these are also with E2. But how router can understand that these prefixes, which prefixes I am getting from EIGRP 100 and which prefixes I am getting from EIGRP 200? Yes or no? So guys, while redistribution, when we will perform redistribution, we can add one tag number. Yes or no? So that here we can identify that these prefixes are coming from EIGRP 100 and these prefixes are coming from EIGRP 200. Yes or no? And because if you want to filter the traffic, suppose router 1 never communicate with EIGRP 100 domain. So why router 1 will install these prefixes in their routing table? So we should filter these prefixes. Yes or no? Unnecessary router will not install any route in their routing table that router don't need to communicate. Okay, so here let me make you understand that how we can add tag while redistribution. So on router number 2, first of all I am going to remove this command, say no, and let me put it. After that, redistribute EIGRP S number 100. Here we need to use keyword that is subnet, and then we can use metric type. So let's say metric type is 1, or you can skip metric type as well. Suppose I don't want to use metric type over here. Directly I want to add what? Tag. So here you can use this one, tag option. And here I am adding tag what? 100. Actually I am using tag number with AS number. So whatever prefixes I will get on router number 1 with tag 100, I will get to know that these are prefixes coming from EIGRP 100. Done. In the same way, on router number 8, I will add tag number what? 200. I will add tag 200. Router OSPF 1. So run section OSPF. So this command I need to remove it from here, config T, and say no. This one, sorry, a router OSPF 1, say no, and after that redistribute EIGRP 200 subnets and tag 200. Here I have bad tag to 200. Now on router number 1, you can check. Enable so IP OSPF database. So IP OSPF database, here you can see these prefixes are coming with tag number 100, 200, 100, 100, right? So all the prefixes where tag number is 100 are coming from EAGRPS number 10, and all the prefixes with tag number 200 is coming from EAGRP 200. Yes or no? And now if you want to filter the traffic, so you can filter also. Suppose this router 1 don't need to communicate with 60 prefixes which is running in EAGRP 100 domain, or suppose router 1 don't need to communicate with EAGRP 100 domain. So what we can do, we can create one route map over here, route map, and after that name of route map, let's say name is CCNP, and I am going to create a route map with deny statement, yes or no, and I am saying match tag number what 100, yes or no, and I need to make one permit statement route map. So route map CC NP permit. Okay, sequence number 20. Done. If I will not match anything, it will match all. Router OSPF 1 and distribute list. Distribute list. After that, here we can say route map, and name of route map is CCNP, and in which direction? In direction. Whenever you will filter the prefixes in OSPF, you cannot apply distribute list in odd direction, because OSPF not share routing information. Where OSPF share what? LSAs. So now here if you will run routing, if you will check routing table now, so IP route OSPF, you can see this router is not receiving any 60 prefixes now. Yes or no? See the routing table. But in the database, so IPOSPF database, in the database still you are able to see the 60 prefixes, yes or no, with tag number 100. But it will not install it in routing table. Okay guys, so IP route. So actually this router will install 60 prefixes via router number 460.1.1.0 or not. 60.1.1.0 which is running on router number 10. This router is not getting that prefix. Okay, let me verify it on router number 7. Let me check that router 7 have 60.1.1 prefix or not. So IP route OSPF 60.1.1.0 is reachable via 78. Yes, here you can see 60 prefixes there. 60.2 is reachable via router 5 and router 4, and 60.1 is reachable via router number 8 directly. So on router number 1, why I'm not getting it? Let me check on router number 4. Enable. So IP route 60.1.1.0 255.255.255.0. Here also route is available via 47.7 and 14.1.1.1 via router number 1 also. This router is getting prefix, yes or no? But router number 1, so IP route 60.1.1.0 255.255.255.0. It is saying network not in table. So IP protocol. So here you can see outgoing update filter list for all traffic is not set, and for incoming traffic route map is running. So it should receive 60.1.1 prefix, but I think I have configured something over here. So IP OSPF database. Okay, on router number 1, let me check the OSPF database. So IP OSPF database, and here external prefixes LSA 5. So 60.1.1 dot is there via router number 8 with tag number what guys, with tag number 200, but it is not installing in routing table. Why? Because it will install this path in routing table, but we have configured one route map to filter the prefixes with tag number 100. That's why you are not able to see this prefix in routing table. So what we can do, we can increase the cost over here on F0/0. So let me take you on interface F0/0 and say IP OSPF cost is, let's say, 5. Now if you will check routing table, so IP route 60.1.1.1, still it's saying not in table. Yes, now you can see this prefix is there. Okay, so actually earlier what was happening, it was receiving the prefix from router number 2 with least cost to reach 2.2.2. That's why it was installing that route in routing table, but route map was filtering that. Okay, so till now we had discussed path manipulation, and this is also one kind of path manipulation, because we have configure the route filtering so that router 1 will not install any route to reach in EAGRP 100 domain. Okay, so now we are not going to understand anything else in this video guys, because video length is already large. So if you have learned something from this video, please hit on like button. We will meet soon in next video. Till then, stay safe. Bye bye guys. There are lots of advanced things are pending in OSPF. Definitely I will try to cover everything in next video. Thanks for watching guys. Bye bye.